Hello everyone, this is Egor Nika, and today I will talk about an IP camera with low latency and a frame rate of 120 FPS. The camera is called Enjoy and is based on the SigmaStar SSC338Q chipset with the IMX415 sensor. I would like to note that there is a similar camera on this chipset, but from the manufacturer CamHi. They differ in the way the boards are connected and in the storage devices. In my case, it is a flexible ribbon connection and a NOR flash memory, while on the CamHi camera, it is a hard connector and a NAND flash memory. For OpenIPC, a NOR flash memory is recommended. So, let's get started. The camera consists of two boards. One of them houses the sensor. The second processor and power elements are connected by a flexible ribbon cable. Under the lens is an 8-megapixel IMX415 sensor capable of recording in 4K at a sensor output of 90 frames per second. On the side of the board, there are two connectors. One is used to connect the infrared lens curtain, while the other is for turning it on and off. On the back side of the main board, there is a 16 MB NOR flash memory chip. And on the front side is the SigmaStar SSC338Q chip system. This chip is located under the heatsink. I probably won't remove it. In addition to the chip system, there are voltage conversion components and elements such as connectors for external devices. The upper connector is for the contacts that control the motors and the camera's rotation. Next is the reset connector, followed by the USB connector below. A Wi-Fi module is usually connected to it. The next connector is for audio input and audio output. The module for the SD card is connected to the lower header. On the right side is the UART connector. You can connect a flight controller to it and output telemetry there. And the last connector, here, two contacts are for power at plus 12 volts and 4 are for the LAN network. There are two more contacts for LED indication. According to the standard scheme, an input voltage of 12 volts is supplied to the first 5-volt converter, and from there, it is converted to all other voltages. Let's connect the power and measure the voltage at the addresses. This information will be useful in case of camera repairs. Here 1.5 volts 3.3 0.9 and in addition to that, I am interested in measuring another 5-volt choke, which is specifically located on the sensor board. And in this particular instance, we have a measurement of 1.16 V. The chip system includes two Cortex-A7 processor cores with a frequency of 1.2 GHz. This system can also encode video in the H.264 and H.265 codecs at a resolution of 4K and a frame rate of 20 frames per second. If we remember, the sensor can output 90 frames per second at the same resolution, but it seems that the processor's power is insufficient for this. The weight of the camera without the lens is 21.6 grams, and with the lens it totals 34 grams. We will install the OpenIPC firmware on the camera. To do this, we will connect the USB TTL adapter to the technical UART port. This port is located at the bottom of the camera and consists of two small pads. To solder to it, you need to have a very small soldering iron tip. In addition to the TTL adapter, an additional cable is needed, which includes power and connection to the LAN network. The firmware recording is done according to the standard procedure described in one of the videos on my channel. More detailed information can be found in my Telegram channel. After completing all the procedures, the wires can be desoldered or left in place if you need a second UART port. Further firmware updates are done over the local network. Let's move on to latency. Using a special device, 200 measurements were taken and entered into an Excel spreadsheet. And then a graph was constructed here. Measurements were taken for two configurations. This is Full HD at 90 frames per second and HD at 120 frames per second. and for two monitor modes of 120 Hz and 140 Hz, the minimum latency was achieved in 720p 120 fps mode, averaging 52 milliseconds. 20 fps also averaged 52 millis. In this mode, the minimum latency was typically 28 milliseconds, but such values were not encountered frequently. This table also allows you to view the latency measurements for other configurations, as well as see all the measurement values. By the way, the value of approximately 28 milliseconds or so is shown in green. All measurements were conducted on a test bench with the ground segment of the orange P5 Plus, connecting the camera to a 100 megabit per second LAN. A 2K monitor with a refresh rate of 144 fps. The configuration from the Majestic file is also provided. It turns out that at the moment this camera has the best latency, but it certainly still doesn't match the analog cameras in any conceivable or imaginable way possible. After the data was published in the OpenIPC group, it became clear that the data did not match the measurements of other users. They recorded a latency of about 30 milliseconds, and so I started to look for the reason. I installed FPV View. This is software that was written for decoding video on the ROG chip. It also uses GStreamer, but it is implemented in screen mode. That is, all resources are dedicated specifically to this video stream. As a result, the new latency measurements were around 32 milliseconds, which is 20 milliseconds better than when measured in windowed mode. The IP camera has two main shooting modes. The first is the high-speed mode, which has a frame size of 720p and a frequency of 120 fps. In this mode, only a part of the sensor is used, known as crop mode. This is specifically designed to significantly increase the overall frame rate and enhance overall performance. The second mode is essentially the binning mode. In this mode, the entire sensor is used, but adjacent pixels are combined into one, in essence. So we end up with not a 4K image, but full HD. In this mode, the latency increases by only 7 milliseconds. So if you definitely want a very good quality and high resolution image, such as when you are using binning mode, and if you want a picture of not very good quality but with minimal latency, fly in HD 120 fps mode. It is also very important and necessary and essential to carefully select the appropriate and suitable lens for these modes. For the crop mode, it is better to use a lens of 1.4, 1.7. And for the binning mode, you can use any other suitable lens. This camera is available on the market with two sensors, IMX415 as shown in the video, and IMX335. The OpenIPC firmware typically works with both sensors and produces roughly the same results, but user feedback indicates that the IMX335 sensor is preferred for its image quality. I am indeed curious to know how many pixels are used in each sensor, but I am currently unable to obtain this information from the developers. The thing is that the IMX415 is more powerful, as it allows shooting 4K at 90 frames per second. The IMX415 has an auto frame rate of 33. The IMX335 has 5 million pixels with a polling rate of 60 Hz, which is significantly lower. Therefore, I am curious about how many pixels are utilized in each sensor at a frequency of 120 frames per second. I will try to find out this detail and shoot a separate video. I think I'll wrap it up here. If you have any questions, feel free to ask them in the comments under the video or in the Telegram channel. I will leave useful links in the description. This was Igor Nika. Goodbye everyone.